Mm. Once again, this is a celebration of science, and we are organizing a good event of 4.0 India International Sarabhai Student Scientist Award 2023. And for promotion of this, I am here, myself Anjan Banik, being a national chairman of whole event, as well as I am welcoming on behalf of National Council of Researcher Teacher Scientist India, National Council of Student Scientist India, and the event organizer DASA India, the National Voluntary Non-Profit Science Organization of Science Communicators for Science Communication under the registration of Government of Tripura, and also the councils are affiliated to VIPNet, Vigyan Prasar Network, under Vigyan Prasar, an autonomous organization of Department of Science and Technology, Government of India. So welcome all. Today we are going to celebrate a great day, an auspicious occasion. I have to speak more occasions. First of all, whole India is celebrating the National Children's Day. And another thing is that today is most precious because today is the birth anniversary of Professor Birbal Sahni, the great paleobotanist on whose dedication we got an prestigious organization at Lucknow on Paleobotany segment. So today is more auspicious day, and today it will be added value by NASA people also, because we are conducting a great event that is meet the scientists, meet the engineers of NASA. Yesterday session we invited engineer Gabe, and today if a network is blessed to us, then we will meet engineer Dr. George A Salazar from Jhonson Space Center under NASA. It is more important because today is most auspicious day also, as it is the Eve webinar, and we are also going to celebrate on 16 November the launch of Artimis 1, the prestigious and history-making rocket of NASA, which is going to an unmanned mission after a long time. It is going to moon, and again it will come back to our Earth. So it is a very historical mission, and it is happening on 16th. The launch will be on 16th November after a day, then tomorrow, and the timing of launching is 11:30 according to the Indian time. So we will be celebrating that one also on this crucial moment of launching. Engineers from NASA has given us one time, though he is very much busy with different tasks related to Artemis also, but he hopefully he join, and we will invite him and get one lecture on a very prestigious topic, that is human space flight, NASA, the history of NASA, and as ISRO is also going to make an one history with Gaganyaan mission. Today we will be blessed with the presence of ISRO scientist also from he is staying now at USA, And from USA, he is also joining us today. And a little bit we will discuss on Gaganjan. He is none other than our most prominent advisor, engineer, Dr. Bharat Bhai Chaniara sir, who have dedicated him for almost 35 years in ISRO SAC Ahmedabad, and also dedicated for EduSet missions. So be with us. And once again, I would like to remind you all that we will serve one great certificate of participation for this webinar if you keep records with your comments and with your screenshots and send to us on our WhatsApp group and email. It will be better, and we will serve you the certificate of participation signed by our NASA scientist. So it will be a great thing from our side. Self. To in Facebook and YouTube, you just keep your comments and also keep your record that you are joining here. So any moment our guest will join, we will be there. Before that, I would like to share something, the inaugural part.
हरि ओम सहना भवतु
So great going. Within a few minutes, we'll be with all our participants. So be with us. Uh, Once again, good evening to all our participants. We are online now. We are online in our all the social medias. So it is requested to be maintain the dignitaries of the event, and we will go ahead. First of all, I would like to remind all of you today is a great event for all of us as NASA people are giving appointment to discuss their findings and opportunities in the field of space science, and giving a lot of time to us. But due to some technical issues, you already experienced when last 6th November day, Gabe from Kennedy Space Station join us and discuss all about NASA. Some technical issues may remain with them. Today, we know this is a day of National Children's Day, celebrated all over nationwide, nationally, and also not only it's a birth anniversary of first Prime Minister of India, uh, who adopted the constitution, Pandit Jawaharlal Nehru. Also, in the field of science in India, today it is a birth anniversary of uh, great paleobotanist, to whom we can say he is the father of the paleobotany science, uh, our respected Professor Birbal Sahni. So 14th November, it is a very prestigious day, and above all, today is another opportunity that we are celebrating the day when first time some USA astronaut Edward White too, who born in 14 November 1930, the first USA astronaut who walked in space with James A exhibit. So this is a very prestigious day, 14 November, and today we are going to meet engineer Dr. George A Salazar once again, who will discuss on the topic of uh, human space flight, history of NASA, and the opportunities of uh, ISRO. Before that, we are also blessed with the presence of our ISRO scientist who dedicated his life for more than 33 decades to ISRO ISAC, uh, Ahmedabad, and also dedicated for EduSat mission. Dr. Bharat Bhai Chaniara sir from NASA, from USA, he is joining today also, and we are starting with his little bit talk about ISRO's mission and ISRO's opportunity for Gaganyaan. We will confirm him for another session, a very individual session, an exclusive session on Gagan mission, and sir has agreed to do that one also. So on another day we will take his another very individual exclusive session, but today we have invited him today for some talk about ISRO opportunity on Gaganyaan mission. So I would like to invite Dr. Bharat Bhai Chaniara sir, ex ISRO scientist, uh, who is joining from directly from USA, and will discuss on ISRO's opportunity on human space flight. Over to sir.
Thank you. Good evening to all of you. First of all, I would like to thank Mr. Anjan Banik, who has provided this opportunity me to speak to you, all participants. And also, congratulations for arranging such a webinar related to new technology, new space missions, and all such things. So it's a great thing. I think all participants will enjoy it and they will gain some new knowledge in the space science. I would like to share my view, my knowledge to all of you related to our Gagan mission, that is Gaganyaan mission, which is going to happen in near future within 1 year, 2 year. So Gaganyaan is our first space mission. That is first initially it will be Manikji, shall I present through PPT?
Yeah, sir, please share. Minimize the screen, sir. No, sir.
Okay, are you getting?
Getting, sir. Do it full screen, sir.
Yeah.
Fine, sir. Fine, sir.
Okay. So today I will be speaking about Gaganyaan of India. Just a brief description about Gaganyaan and what is that one and what is our purpose. So Gaganyaan will be the India's first crewed orbital spacecraft to carry 2 or 3 astronauts along with Vyom Mitra. Initially, there will be 2 maiden flights, means there won't be any astronauts in that initial 2, that will be experimental or test flight, we can say. And third will be crewed mission, means with astronaut, third flight will be with astronauts. It consists of an autonomous, means it is that Gaganyaan will be fully automatic and computer controlled program, and its weight is 5.3 metric tons of crew module, and 2.9 metric tons of service module. And total weight will be 8.2 metric ton of capsule which will be orbiting in the space. So then is crew module, and another one is service module. Diameter will be 3.5 meter. Its height will be 3.58 meter, and volume will be 8 cubic meter, and that will be orbiting around the Earth in circular orbit around 400 kilometer altitude for about 7 days with 2 or 3 astronauts inside the capsule. And this Gaganyaan will be launched by GSLV Mark III, means Mark III launch vehicle, which is our heaviest launch vehicle of ISRO for India. The service module propulsion system, that is SMMPS, will help in orbit raising maneuver of Gaganyaan to reach 400 km in lower Earth orbit. Means when it will be launched with this Gaganyaan will be launched with GSLV Mark III, it will be launched in a lower orbit. It may not be, it won't go up to 400 kilometers. So once it is separated from GSLV Mark III launch vehicle, then Gaganyaan will be, the orbit of the Gaganyaan will be raised by this service module, which is this one. You can say this is service module, this is astronaut module. So astronauts will be sitting in this upper module, that is crew module, and this is our service module, which is used to control the capsule, that is astronaut module. Hindustan Aeronautic and Defense Research Development Organization, these 2 organizations are supporting ISRO for this mission. They are providing certain components, technology, and all these things. So they are supporting partner of ISRO for this Gaganyaan mission. In Gaganyaan mission, there will be 5 experiments will be carried out, which are related to physics, biology, and medical science. While returning this Gaganyaan to on Earth, the parachute will reduce the speed of the screw module from 216 meters per second to almost less than 100 meters or 11 meters per second at slash down in Bay of Bengal. So Gaganyaan will be returning Bay of Bengal. The crew module heat shield during this returning flight, this heat shield, this outside will be fully, it will be heat shield. That will experience around 1600 degrees centigrade temperature due to friction of atmosphere and speed of this capsule or astronaut crew module. In this mission, so far, whatever milestone achieved, I will tell about briefly about that milestone we achieved. The crew module atmospheric re-entry experiment, that is called CARE, C-A-R-E, without crew means unmanned. It was carried out with a dummy, requisite dummy load, successfully on 18th December 2014. So this experiment was already performed in 2014, and it was launched and it was recovered from the Bay of Bengal. But at the time it was dummy load, there was no, it was unmanned. The test flight was used to test the, so this test flight means CARE experiment was used to test orbital injection, capsule suppression, heat shield performance, procedure of re-entry, aerobraking system, development of parachute, deployment of parachute, retro firing to reduce the speed of capsule, splashdown, floating system. When it lands in the sea, floating system has to perform, otherwise it will sink. And recovery of the crew module from the Bay of Bengal. So this all system, all technologies, new technologies were tested during 2014, that is CARE module test experiment. ISRO also conducted paid EPSOC test successfully on 5th July 2018. Testing of IISSSA engine, which is a core stage of cryogenic engine, and upper stage of GSLV Mark III launch vehicle were tested successfully on 14th July 2021 and 12th January 2022 respectively. The service module propulsion system was tested successfully on 28th August 2021. The static test of strap-on booster, that is S200 of GSLV Mark III launch vehicle, was also carried out. This Gaganyaan mission, it will carry Vyomitra, that is humanoid, we can say. So along with the astronaut, initially in 2 test flight also, it will be there in unmanned mission, and in 3rd flight, that is with the astronaut also, it will be there. So that is Vyomitra, that is humanoid. Vyom means space, and Mitra means friend. So it is, you can say, robotic friends along which will fly along with astronauts and in initial 2 test flight also. So Vyomitra is there, female-looking robot, which will be a part of 2 uncrewed experiment mission and also accompany 2 other astronauts in the crewed Gaganyaan mission. That is in 3rd flight. It will perform microgravity experiments, monitor module parameters, and support astronauts by stimulating functions exactly like humanoid. It is programmed to speak Hindi, English, and perform multitask functions. It can mimic human activity, recognize other humans, and respond to their queries. It can perform technical tasks like environment control of the module, life supporting system functions, handle switch panel operations, provides air pressure change warning to the astronauts, and if required, it can change the temperature of air condition also, which is inside the capsule or Gaganyaan. It can autonomously complete tasks and follow the new ground command from the ground control Earth station. So cruise space flights of the world, so far whatever in the different countries of the world who has carried out crewed space flights. The detail of this, the first flight that was first one was launched by Russia in 1961. Then subsequently different 13 types of different spacecraft were developed, and they were made crewed flight in the space at different altitudes. So out of these 13, 9 flights were from America, 3 flights from Russia, and 1 flight from China. India could be the fourth country in the world to carry out such a crewed space flight mission. So we may be
Sir.
fourth in the world for this type of space flight. Yeah, please.
Sir.
Okay, thank you for your kind attention. Thank you. Yeah.
Sir, Chaniara sir, we will be grateful that already George Salazar is with us. I would like to, sir, with your permission.
Okay, fine. Okay.
I would, with your permission, I would like
Yeah,
to invite.
please, you can go ahead. You can have. Yeah.
So
you can go ahead.
Thank you, sir. Thank you, sir. It's a very prestigious occasion when NASA from NASA Jhonson Space Station Center engineer George A Salazar joined us, and it's a tremendous occasion when to in receive him. We have with us Bharat Bhai Chaniara sir, ex ISRO scientist who have dedicated his 3 decades of journey with ISRO SAC. So I would like to invite our most awaiting invitee, George Salazar. Uh, Salazar
Hello.
is yeah. Good morning and good evening, sir.
Good morning here, good evening over there.
Yes, sir. And to receive you, we have with us Bharat Bhai Chaniara, sir, the ex ISRO scientist who served ISRO for over 35 years. And now even now he is also in your US. From US he joined us to receive you. So it's a great event when we are receiving George A Salazar, Dr. George A Salazar. Even when whole NASA is busy with Artimis 1, as this is will be scheduled on 16th November, just day after tomorrow, as per according to our Indian time, 11:30 is the timing. So at this busy moment from Jhonson Space Center, engineer Dr. George A Salazar is with us, and he will discuss the human space flight, the NASA's history and opportunity in future, as well as ISRO's dream, which is going
one day in the future, we're going to have joint missions where we have people from, different parts of the country, and even people from other worlds. Spock was from the planet Vulcan. And so, these are some of the exciting challenges that lie ahead of us in terms of space exploration. There's so much to learn. So I'm just going to briefly talk about the brief history of human spaceflight, primarily from the NASA side. And then I'm going to talk about planned human spaceflight programs. I'm going to talk about the challenges, because this is the biggie. This is not easy to solve. There's a lot of problems to solve before we can start going to deep space like they do in Star Trek. And then I'm just going to talk briefly about NASA systems engineering and human systems integration process. And I'm going to talk this at a very high level, but this is kind of a procedure that how we approach complex problems. And it's very similar to the way scientists look at problems using the scientific method. So I'll say some brief words about that, and I won't get into a lot of details, because that could be an all-week discussion about those systems engineering and human systems integration. And human systems integration basically is considering the human part of a space flight. All right. So just a couple of notes that I'd like to share with the students is a reminder that India International Student Science Award is through the eQuiz Astro Olympiad, January 23rd for all students. So don't forget to register for that. And then the second thing is I just like to acknowledge and thanks the National Council Research Teachers, as well as the National Council of Students of India, Chairman Anjan Banik, for inviting me to speak to you all. I appreciate it. So that's human spaceflight program. We started with a Mercury program. So the Mercury program was to try to understand what it takes to for humans to live and work in space. We didn't know anything about that. And yes, they're not showing up. Hello? Are they?
I think,
okay, so let me get.
I think you can put in presentation mode. Yeah.
Okay. Well, I'm going to get back into the presentation mode. And can you see that first picture of Mercury? Okay. Okay. So you see all the slides, huh? Huh. Okay. Interesting. All right. Let me try to share again.
Dr. George, you can go to presentation now. That you can click that arrow, which is at bottom.
Yeah, I'm picking. I got 3 screens here, so I'm hoping that what you see is.
You can go to presentation full screen.
All right. So when I go to present. Okay. Do you see the presentation mode? All right. So let's see here.
Sir, please click this button, which is it full screen presentation mode. This one.
Do you see that? Full screen?
No, not yet.
No. Huh. Interesting. All right. Well.
Sir, click bottom one. Please click this button. Please click this button, presentation, this button. This one at the bottom of the screen of PPT.
Yeah. Yeah. Yeah, these are some of the okay.
Excuse me, Sir Salazar.
Let's see. I'm a little stumped here. All right. So you see that. You can see my first slide. Okay. Right. Yeah, when I go to slideshow, I hope it doesn't change anything. Did it change?
It won't change. You can go to slideshow.
Okay, so do you see the first slide in presentation mode? All right, so I'm going to go to the next slide. Can you see that? All right. So
still it is not in presentation full screen mode.
All right. So this is something that's happened to. All right. So do you see that? So do you see the topic slide? Something's okay. So when I go to presentation mode, does it show topic slide bigger?
Yeah, it will be bigger full screen.
Okay. Okay, and I do have full screen mode. Something's going on that I'm not sure. Let's see. Yeah, I show here. I show here full screen. So something may be going on Google, and let me try this. Does it go? If I does it show the at the top a couple of notes? Okay, but you're seeing. Are you seeing two screens on your side, or just one big screen? Wow. That is so weird. If you're seeing all the slides, because on my side, I just selected one slide and go to topic mode. So, man, okay. So right now, what I'm seeing is that I see all the people that are online, and I see a couple of notes. The slide that says a couple of notes. All right, so there's something going on with presentation mode in Google, and this has happened to me on 2 occasions. So what I'm going to do instead is I'm going to switch to the next slide and not go into presentation. All right. So I'm just going to present non-presentation mode because I don't know what it is about Google, but it just doesn't work for me here in the United States. But be that as it may, what you all can see is the different space programs at the very top and also at the bottom. So we started with the Mercury program. You can see the Mercury program, and the Mercury program was intended to learn how to live and work in space for humans. And you guys are getting involved with human spaceflight. And I'm sure you have read a lot about, human spaceflight and what it's going to take for humans to live and work in space. There was a lot of concerns about humans living in space. That they were worried that they couldn't eat. They were worried about sleep. They were worried about the muscles. They were worried about bones. And so there was a lot of concerns, but they were able to overcome many of those concerns. And then came the Gemini program. And the Gemini program became more complex. They had two astronauts, and this Gemini program had the capsule had a computer. It was the first computer in human spaceflight. Mercury didn't have a computer on board. All the commands were sent from the ground. And then the Apollo space program, that was the one that took us to the moon. And interesting enough, even though we had a total of 6 missions that landed people on the moon, the total time spent on the moon was 3 days, about 3 days. That was it. 3 days total. It was very challenging. There was a lot of issues associated with trying to land humans on the moon. One of the biggest problems of the moon is the dust, the lunar dust. The lunar dust, one person told me at the Jhonson Space Center, he said it's like crushed glass, very abrasive. It can cut you. It can create problems for mechanical systems. Gene Cernan on Apollo 17, that was the last mission to the moon, said that the biggest challenge of going to the space, rather the moon, was the space dust. The space dust was just awful. And it created problems for their lungs. It created problems for the mechanical system. And that's something that we're just going to have to overcome. And then we went on to the Space Lab. Space Lab was the first orbiting space station. I understand that India is going to be developing a space station too as well. And so for us, the first cut of the space station was Skylab. And it only lasted a few years, and then we got into the space shuttle program, which was the first reusable vehicle. Reusable in terms of the main engines, reusable in terms of the solid rocket boosters. And of course the space shuttle that looked like an airplane. Interesting enough, the shuttle launched like a rocket. It orbited the Earth like a satellite and came back down to Earth like a jet airplane, if you will, traveling at something like 20,000 miles an hour. It's coming in quite fast. All right. So let's talk about deep space missions, because deep space missions is what we're going to be looking at now, and hopefully we're anticipating India getting involved with this. And the thing is that right now, space station is orbiting around Earth, and they very much depend on mission control, as well as something like close to 50 to 75 people on the ground to help maintain the station in terms of maintenance and in terms of safety, keeping it safe. And so we have a lot of people that are looking at the space station right now. And one of the reasons that can happen is because of the delays in communications. The delays is very small. And so you can look at information very quickly and determine if there's a problem. If there's a problem, they can send commands to try to correct the problem. Not so when we start going deeper into space. When we start going deeper in space, the time delays get longer. It's going to take longer to talk to somebody on the ground. Like, for example, going to the moon is not going to be so bad, maybe 2 or 3 seconds. I say hello, and somebody on the moon is going to say, hear hello about 3 seconds later. We go to Mars, I say hello, when a person on Mars is going to hear hello like 20 minutes later, depending on how far Mars and Earth are close. And so these delays are going to be problems. These are going to be big problems for the crew going into deep space. And so we're going to have a lot of computer systems, artificial intelligence, intelligence systems to help these astronauts operate a complex vehicle. These vehicles are going to be very complicated. So we're going from, and that's what this arrow shows, we're going to go from where the crew is dependent on mission for the operation of the vehicle and the mission. We're going to be going to, now the crew has to depend on them. They're going to have to depend on the vehicle in order to be successful. They cannot depend on mission control on Earth, just simply because it just takes too long to communicate, especially in emergency situations. And so what you're seeing here is a phased approach going to eventually Mars. Right now we're doing Earth, kind of a Earth low Earth orbit mission, and it's what we call Earth-dependent technology. So obviously, SpaceX will help them. And of course, we got commercial partners. We got SpaceX. We got Boeing. We got Blue Origin. These are commercial companies. They're providing services to send humans to space station. Well, now when we start going to the moon, and this is the Artemis program. This is the next program that's going to take us back to the moon, but not temporarily like we did on Apollo. This to take us back for a long period of time. And so we're going to have to learn and live and operate on another planet for a long period of time. And so what we're going to be doing is going to be basically what we call a dress rehearsal for eventually going to Mars. Because once we go to Mars, we're going to be too far away for emergency situations. So all these systems that we develop on the moon are going to have to be very reliable. They're going to have to work all the time in that moon environment. And if once we're ready, then we go to Mars. We cannot go to Mars without knowing that we're very confident that our systems are going to operate. And I'll say a little more about that later in my presentation. All right. And so it's going to take a lot of people from different countries, from different areas of commercial sector, government, to make this happen. So we're going to have the gateway. The gateway is kind of like the orbiting moon space station, if you will. And so that gateway is going to be a permanent orbiting station around the moon. And then we're going to have a human lander system. Right now, I'm currently working with SpaceX on a human lander system. It's going to be quite challenging. We're going to have also additional commercial partners for developing systems, for me to use on the moon to develop what we call the infrastructure, all the key elements that are needed in order to support humans for a long period of time. And then, I show here a picture of Indian Anjan program, which is your program in terms of human spaceflight. You guys are eventually going to be the fourth nation being involved in human spaceflight. You've already developing a spacecraft. You developed a launch abort system that was recently tested. And I think you have already testing, you developed some has to train on these systems and eventually do a low Earth orbit testing of all these systems. So that's going to set the stage for India to start joining other countries like China, Russia, and the United States in human spaceflight. And I'm sure they're going to find out that it's not simple, but at the same time, that's how they learn to live and operate in outer space. So, congratulations to India in undertaking this. This is a major undertaking, but that's how you're going to evolve as eventually what we call a spacefaring country, where you're looking at the future of your country in space exploration. And let me just talk now about the human needs and challenges, and these are just a few that I'm showing here. But the thing about humans going into space is that we got the gravity that affects the human body. The gravity can affect the generation of calcium. So calcium is used to build strong bones. Well, on Earth, because we have the one gravity environment or one atmosphere environment, our bones tend to become strong in order to resist the gravitational pull here on Earth. Well, as we start going deeper into space, that's not the case. And so we're going to have to learn how to maintain bone and muscle mass. And so we do that through exercise and through certain vitamins and things of that sort that we give to astronauts. Now, the real big one is, you see there, space radiation. Okay, space radiation, it's a major challenge. And of course, for the human, the space radiation can affect your mental abilities. It's called something, I think it's called central nervous system cognitive decline. So what does that mean? That means that your ability to think, to rationalize, to reason starts to go down as you get exposed to more radiation. So trying to protect the astronauts against the deep space radiation is a major challenge. The other challenge is isolation, being away from family for a long period of time. Going to Mars is going to be like a 3-year mission. And so they're going to be away from loved ones for a long period of time. We don't know how humans are going to behave when they're going to be gone for such a long period of time. Sure. We've done studies here on Earth about people being confined and isolated for about a year. Recently, Mark Kelly on Space Station did 1 year up in Space Station. But as I've been learning, talking to some of my human factors and physiological, psychological colleagues, is that we still don't know how humans are going to behave when they're far away from Earth and they see Earth as a little tiny dot. So that's going to be a major challenge too as well. How do we get over that? Not sure. Obviously, having the ability to communicate with loved ones is a big thing. And then perhaps other factors that we're still looking at. And of course, the other one is the hostile environment on the moon. There's the gravity is very small, 1/6 the gravity of Earth. And so we're going to have to protect these astronauts. And of course, protecting astronauts is a major challenge in terms of how big to build these systems in order to have to make that happen. And of course, medical emergencies. Things are going to happen. Somebody's going to cut themselves. Maybe they get an appendicitis attack while they're on the moon. Well, are they going to have to operate on the moon because it's an emergency situation? And so these are the things that are going to be a challenge. One of the things that some of the people have not thought about, and even in my own agency, NASA, is that some of the medical equipment that's here on Earth that's used in hospitals will not work in the space radiation environment. They're not designed for deep space radiation. So how do we design systems that are usable for deep space? That's also a major challenge. So I just right now I just talked about human needs and challenges, and now let me talk about technology challenges, and these are just a few that I'm going to share with you. One of them is power. All right, so power, it's going to take a lot of power to operate these settlements, if you will, on the moon. Right now on Space Station, those solar panels generate somewhere in the vicinity of 75 kilowatts of power. And of course, we get they get a lot of sunlight, so it's not a problem. But going to the moon, especially on the dark side of the moon, there is very little sun, depending on where we land. And so generating solar power, energy from solar cells, is going to be a major challenge. And so we're looking at other alternate things like nuclear energy, perhaps, or radio, what they call it, radio thermoelectric energy as well. Robotic systems. We're going to need robotic systems to help astronauts. Every time an astronaut goes outside of the space capsule, it's a risk. And so if we can get robots to do work for the astronauts outside of their habitat or their spacecraft, it'll make things a lot easier for them, because robots can handle radiation, they can handle the thermal effects, the temperature changes, and all that. So that's another challenge. Another challenge is what you see here: human interface. The human interfaces for these deep space missions are going to be complex because there's so many systems to operate and monitor that we're going to have a different way of looking at human interfaces with the human interface between the machine and the human. And then the habitats, obviously the habitats is going to be very important, ensuring astronauts are safe at all times. Communications is also a biggie in terms of just communicating a lot of data with the Earth and sending it very quickly. Right now, the transmission speed is not quite as fast as what we would like. So things like augmented reality is transmitting between Earth and Mars using augmented reality or goggles. The amount of data required for that, we're just not there. We have to develop better ways of sending high-speed communications. And then I just mentioned medical systems earlier in terms of handling the radiation environment. And then finally, up here at the top is making water out of plant soil and planet, to grow food. The thing about some of the soils, like for example Mars, is kind of toxic. And it's not good for growing plants on using Mars soil. Making water out of the moon soil as well as the Mars soil, we're looking at that, but it's not easy. I talked to some of my colleagues working what they call in situ resource utilization, and right now they're experimenting with this big system, big as a room, 20 feet by 20 feet. And, they use about 3 pounds of simulated Mars regulo, 3 pounds of dirt, just to create maybe about 2 ounces of water, very little water. And the water smells terrible, and I wouldn't even drink it. So there's still some challenges there. So how do we make these systems happen? And it's something called systems engineering in human spaceflight. And I'm not going to get into a lot of details, but basically it's a planned, methodical way, step-by-step way of developing complex systems. And so, this is something called the V diagram. And the V diagram basically says on the left-hand side, you start to define what do we want to build, what do we need, what is required, okay? And then once you got that, then you start developing solutions, okay? Similar to the scientific method, right? Scientific method says make observations, perform a hypothesis, design an experiment, conduct the experiment, gather the data, compare the data against the hypothesis, and see if you're right or wrong. very similar in systems engineering and human spaceflight, spacecraft engineering, is that we're basically forming a hypothesis. This is what we're going to need to make this mission happen. And then we design these systems, we test these systems, and we compare against what we thought is needed for the mission. And if it's not, then we have to figure out what do we need to do to correct it or maybe make it better. And that's the challenge of systems engineering. At the bottom here, you see the technical management process. And this is critical. This is the people that are making sure things are being done at the right time, and they're looking at the data to making sure they're getting the right data. And I can't tell you how much time I have spent in the technical management process at NASA over the years. This is definitely critical. Things like risk. We have risk. How do we handle risk? First of all, risk is something that can happen. And if it happens, especially something catastrophic, where people die, where astronauts die, we have to look at what the risk is and how can we make it better in terms of making sure that risk does not happen. So the whole technical management process is very important for this systems engineering process. And designing to prevent human error, there's actually three pieces to it. On the left side is basically human rating requirements. Human rating requirements is something NASA has done over the years, has improved and evolved them over the years, is to making sure that we develop requirements, things that we need for this mission that is safe for the astronaut to operate these systems, to make sure that we understand the limitations of a human. You can only do so much. Humans have 2 ears, 2 eyes, one nose, one mouth, and with that we have certain limitations of what we can do. We cannot be looking at 25 screens of information and try to absorb all that very quickly. We just can't do that. So we have to depend on computers. And so that's the challenge of developing these kind of requirements. And then, of course, managing risk. In the middle, we have to make sure this hardware, this software is built correctly. And so that's why we have to test the different environments. We got to test for thermal. We got to test for vibration. We got to test for things like radiation effects, which is a big factor, and leak. At the very bottom, you see a picture of how software, the failure rate of software. Software is not like hardware, and so we have to basically have to do a lot of testing on software to get the what we call bugs or incorrect software out of those systems and making sure they operate correctly. And then we have the human in the loop testing. We got the hardware, we got the software, and then it's executing on machines, and then you've got a human looking at these systems and seeing if he or she are able to operate the system properly. And so this is part of what we call human in the loop testing, and making sure that this interface between the human and the machine does not cause human error that could be catastrophic. It doesn't cause a big workload on the human, and also it's usable. It's I don't like to use the word user friendly, but it's a system that the crew understands well, and they can operate it quite well. And so let me just point out that the whole thing about spaceflight is safety. Okay, people say, what's NASA's first priority? Is it the mission? No, it's not the mission. It's to keep the astronauts safe. That's first. Second is the mission. All right. So safety is the main thing that NASA looks at. And here's something called the Swiss cheese model. And I like the Swiss cheese model as an example of how we at NASA use systems engineering and how we develop systems to try to avoid problems. So, think about each one of these wheels as what we call barriers to prevent an error. Okay, so we got requirements. We developed requirements, and we're hoping that we got all the requirements in there to prevent an error. Design, we make sure we design something that it's not going to fail. And then, safety, we got people in the safety community that are reviewing all the systems, making sure that everything is safe to operate. Training, do we have adequate training for the crew? Maintenance, do we have adequate maintenance? Are we repairing things when they should be repaired to make sure that they don't break down at the wrong time? And of course, the crew health. So you think about all these barriers, and then you say, well, what are these holes? These holes represent a non-perfect system. Nothing is perfect. All these systems are designed by humans, and humans are not perfect. And so these holes basically are things that we miss somehow. And if you think about a hazard, let's say you push a wrong button, and maybe the requirement captured it, and the design captured it, and the safety captured it, and it repels the wrong button push and keeping from having an accident. But there's going to be times where things just line up perfectly. We missed the requirement. We missed in the design. We missed the safety. We missed the training. We missed the maintenance, and the crew was not mentally and physically good that day. And that error, whatever that error is, the wrong button push or the wrong touch on the screen, is going to create an accident. And that's how accidents happen. Accidents happen not because of one thing, because of many things. And that's something that we look at. So eventually we're gonna live and work on other worlds, and we're gonna settle in other worlds. And eventually, hopefully with India and all these other partners, we're gonna go on to other worlds and explore, which is an exciting time. And with that concludes my presentation, and I'm gonna go return control to the group over there. And so thank you very much.
Great, sir. Great session, sir. George, if you permit, sir.
Do you have control back?
Yeah.
Do you have control back?
Pardon?
Can you hear me?
Yes.
Okay. All right. So, any questions? I got about 12 minutes.
Okay. If anyone want to ask any question, if you have some query, please raise your hand and one by one ask your question. First of all, Ayush Mishra.
Yes, sir. Sir, I was having some questions for you. So my first question.
Introduce yourself and then ask your question.
Okay, sir. Sir, I'm Ayush Mishra. I study in CMS grade 6 of Cambridge Rajajipuram Campus 1. And I'm having two questions for you. Sir, like in the beginning of the session, you told that the moon's dust is very harmful for our astronauts, as it is very toxic, which makes them feel ill and they cannot survive. But sir, in moon's dust, there are many important chemicals like potassium zeolite, which can be used. So why can't we use the moon's dust only? Because some of the materials found there can't be found on Earth easily.
Okay, you kind of broke up a little bit, but I know it's about moon dust. So you're mentioning about moon dust and the challenges of moon dust. And we're looking at ways of trying to solve it, but it's not easy. Moon dust has some terrible properties. It's first of all electrostatic, which it attracts to things, and then the other thing, it's very abrasive. So trying to come up with a solution of how to keep lunar dust away from astronauts and spacecrafts and all that is a major challenge. And they talk about mining on the moon, and the machines are going to be mining on the moon are going to have to be lunar dust proof. So it's a major undertaking, but we're looking at solutions and possible solutions. But this certainly we welcome commercial partners and international countries like India, to help try to solve some of these problems, because it's not easy. Thanks for the question.
Thank you, sir, for answering my question.
Next, I would like to invite Dharja Jain.
Good evening, Salazar sir. It's an honor to have a conversation with you.
the probability is kind of low, and I can't give you a number, but it's accept the risk. Okay, that's basically in what we call risk mitigation. Is do you accept or not accept the risk? If you accept the risk, why do you accept the risk? And so you have to show through data analysis why that's an acceptable risk. In terms of cryogenic fuel freezing, the material it's contained in the material used for cryogenic fuel is what's the word? It's acceptable, to store cryogenic fuel. The big challenge with cryogenic fuel is it starts to leak over time. And that's going to be a challenge when we start going into deep space, is that cryogenic fuel storage for what we're going to be calling a fuel depots in deep space is the issue that this fuel might look, this cryogenic fuel might leak out. And when a let's say a spacecraft gets there to try to refuel, there's no fuel because it all leaked out. And so that's one of the challenges in terms of cryogenic fuel for a long period of cryogenic fuel storage. SpaceX is also doing some research in that area too.
Sir, is there more chances of delay of Artemis mission, or it will launch day after tomorrow?
Oh, immediately after launch, space debris.
Sir, I want to ask, is there more chances of delay for Artemis mission?
I'm sorry, can you repeat that?
Sir, Artemis mission will launch the day after tomorrow, 16 November. So, is there more chances of delay, or they will launch?
Yeah, there's always some what they call backup mission timelines that they do, in terms of when is the next best time to launch a spacecraft, and it happened on space shuttle, happened on SpaceX. Sometimes things just don't work out that day of launch, and you got to plan. The whole thing about engineering, spacecraft engineering, is asking what if questions. A lot of what if questions. What if this happens? What if that doesn't happen? What do we do if this occurs at a certain time? And so the whole thing about launching missions, we don't launch it that day, it's our next opportunity. And so for Artemis, we've already had to postpone 3 times, and hopefully Wednesday, Artemis 1 mission is going to launch. So hopefully that happens.
It means, sir, there are chances of delay.
Yeah, next question is from
JSC. It will launch. Thank you.
Yes, sir. Yes, sir. As you said before some time that you are not an astronaut, but becoming a space engineer and an astronaut, what is the difference? Are the study courses different, or it is the same for becoming a space astronaut and a space engineer, or we have to choose different paths, or it is the same?
So you want to know the difference between a space astronaut and a space engineer? Well, so a lot of the astronauts, many of them were engineers, okay? And they got accepted into the astronaut program because of their qualifications of, having a degree in STEM, science, technology, engineering, and mathematics. I can tell you that the astronauts came from different military. a lot of the astronauts, they apply for the for the NASA program. Now, once they get into the astronaut program, they start training differently. They got to train for many things. Okay, this is where you have to have the willpower to study. You're studying about a lot of systems that you in school maybe didn't even learn about. Okay, and so you have to learn these new systems. Okay, so you're learning that. At the same time, you're learning about crew survival. You're trying to learn how to survive. Let's say, for example, heaven forbid that the space capsule has to come down to Earth and it crashes in one part of the country where there's nobody around. In Africa, trying to survive in a area that has no people. So you got to learn how to survive on your own. You also have to learn how to deal with stress. You have to learn how to deal with dealing with risky situations. I was just reading about some astronauts that are training on high performance aircraft in order to deal with the stress of situations where this jet aircraft is going very fast and it's turning and creating a lot of gravitational force on the body. And so how do you handle a situation where you're going at high speed, you got a lot of gravitational force on you, but you're trying to control a system while under those situations? And so that's what's called stress training, if you will. So the whole thing about astronaut training is a huge area. And astronauts train for years before they actually get on the mission. That's why, I don't know if you saw, that, like, for example, Star Trek, the star of Star Trek, William Shatner, went up in Blue Origin, and some other people that have gone up, and now they call them astronauts. I don't think so. Real astronauts do a lot of training before they go into a mission. So I hope that answers your question. But engineers eventually become astronauts if they get selected for the astronaut program.
Yes, sir. Thank you so much for explaining me.
Next, I would like to Harjas Dhillon, and after Dhillon, Divanshi Mehta. First Dhillon, Harjas Singh Dhillon.
Okay.
How efficient the meteor resistor machine? Harjas Dhillon, sir, he sent his question in chat box.
I think he's talking about that asteroid deflection experiment that happened not too long ago. And I mean, I'm not sure about how efficient it is. So that kind of mission is more of not efficient, but was it successful in deflecting it? And now, of course, how effective it is more of the proper term I think you want to use, is how effective was it when they crashed a satellite into the asteroid and they deflected it and to change its orbit. It was deflected into a new orbit, and that's going to be important because one day we're going to see a large asteroid in a direct path with Earth, and we're going to have to find it early and send some way of deflecting it. So it was a major undertaking, and it's. The problem, you talk about risk and probabilities. If you look at the picture of all the asteroids that are orbiting space, you can see that there's a high likelihood that one is eventually going to hit Earth, and we're trying to avoid that. I think a few years ago there was a big asteroid that nobody saw that crashed in somewhere in Moscow, and they took video of it. And when it blew up, it broke windows 10 miles away from the explosion. All right, that tells you the amount of energy these asteroids have, and depending on the size, they can have more energy. Of course, the one that killed dinosaurs 65 million years ago was a big asteroid, 1 kilometer in diameter. And it landed there close to the Yucatan Peninsula, close to Mexico. And that's what killed off the dinosaurs. I need to, I'm going to have to go to another meeting. But I want to thank you all again for inviting me to speak. You guys had a lot of good questions, and I'm glad to see young people out there, and I'm glad to see that the BACNIC's program is inspiring you all to be the best you can, and eventually join the people that are going to be going to Moon, Mars, and beyond.
Correct, sir. Sir, can we take the last question from Divyanshi Mehta?
Yeah.
Last question from Divyanshi Mehta. Yeah, ask.
Hello, sir. I'm Divyanshi Mehta. I'm from Balbharti Public School, Kharghar, Navi Mumbai, Maharashtra. So I had 2 questions. So the first question was, I see a lot of news. So there, once I saw that many of the countries have been working on space debris collector mission. So like Clear Space from UK and other countries. So is NASA been working on some of the projects for this?
What was your question? I didn't quite capture the question.
Sir, she want to.
I'll write in the chat.
Sir, she want to know whether NASA have any plan to collect the space debris. Is there any project in this regard?
Oh, space debris? Is that your question, space debris?
Yes, sir.
Yes, sir.
Yeah, they're looking at different ways of space debris, but it's not a simple problem. It's not a simple problem. If you look at the amount of debris that's orbiting Earth, it's like a junkyard, if you will. Yeah, if we can find ways to clean up debris effectively, it's gonna be good. We put more of a spaceship hitting it, so we got to be very careful about that. And so, yeah, the whole thing about debris mitigation is a major concern for NASA and other countries too as well. So it just poses a big risk to the program. Okay.
Thank you so much, sir. That really helps.
Sure.
Thank you, sir.
Right,
Thank you for.
I'm gonna need to drop off.
Yes, sir. Yes, sir. Yes, sir. Thank you for joining us, and thanks for giving a very informative lecture and guiding our students to promote the 4.0 India International Sarabhai Student Scientist Award 2023. Thanks for supporting. Even more thanks for supporting, as you have agreed with us to sign our prestigious certificate of participation also. Thank you for being with us. We hope such a grand occasion will come again, and we will meet again with George A Salazar once again, time to time. Thank you, and once again for a great day.
Thank you.
Thank you, sir. Thank you.
Hi, sir.
Anjan ji.
Yes, sir. Yes, sir.
Just I want to add something on I think JSN under participants' question.
Sure, sir.
That when we launch any satellite or any mission, no, during that fixing of launch window, time, date, and window time, it is verified that nothing is moving in either space debris or another satellite or any other space missions in the launch trajectory. So collision during launch is very, very negligible. So that is made assured that nothing is moving in the launch trajectory of the mission. So the chances of collision will be very, very less, negligible, we can say. And another question of ZIA, I think selection of astronaut is based on so many parameters, but major parameters are basically technical qualification, then experience in experience, and two more important is physical and mental health, fitness, we can say. That is also very equally important. So pilots from Air Force who had experience in flying in high-speed fighter planes, so there will be a very good chance to select from that Air Force people, pilots. And they have experience, so these are the two major criteria: qualification, experience, physical and mental fitness are major criteria in selection of astronauts. Then later on, once they get selected, they will be trained for what they have to do and how they have to manage the situation. So that training will be carried out, and training will be of the order of, say, we can say minimum 2 years. Training will be there. So that such criteria and training will be there in selection and of astronauts. Thank you.
Sir, I think
thank you so much. It will be allowed.
Sir, I think regarding our Gaganyaan mission, some training program for our astronaut from India, what they are telling that BOMNet, this is also going on, sir. I think in collaboration of Russia.
Yeah. So our astronauts are trained who are going to fly in our Gaganyaan mission. They are trained at Russia, so they are under training at Russia.
Fine, sir. Devanshi Mehta, are you want to ask any question from sir?
Yeah. Actually, that's the reason I raised my hand. So, as being a proud Indian, so I just wanted to serve my country by being a space scientist.
Physics and engineering graduation, that is either electronics communication engineering, computer engineering, IT, and so many other fields also. But major requirement will be from electronics computer engineering will be more. Okay. Other branches like mechanical, electrical are there, but major requirement will be in the field of computer and electronics and communication engineering. So we want to make career in the space field as a space scientist. They have to study either physics and or engineering from the reputed institute. Then selection criteria will come in picture for especially for our ISRO program, or suppose you want to make career in ISRO, then there will be advertisement. You have to apply. Then written test and interview will be carried out. First written test will be carried out. Okay. Who are selected in written test, they will be called for interview. That is a personal interview. And once you get selected in personal interview, then you can join ISRO. So these are the basic process. So normally in ISRO recruitment, there is our centralized recruitment board is there. So they goes on recruiting the scientists, engineers for ISRO's requirement, based on ISRO's requirement. So these are the major criteria for you to study to become a space scientist.
Thank you
Okay.
so much, sir.
Okay.
Thank you, sir. Thank you giving a great guidance to our students. Basically, I would want to like to add, sir has one very good webinar on how to be ISRO scientist, and it is also available. His sir has done that webinar with us, and during 2020 when lockdown is going on, and it is available on our site, our YouTube channel also. So if you have the time, please go through this video, this webinar, and sir has detail form, sir has discussed all these things which will be benefited for you in making the path. So with this word, sir, I would like to end this session with your permission, sir. So thank you for joining us, and we are also inviting all of you students to join our 4.0 India International Sarabhai Student Scientist Award 2023 with a Google e-quiz through Google form based on astronomy and space science and ISRO activity, even different astronomical objects and experiments. So join that one, and it will be this e-quiz and Google form will be open till National Science Day. Each Sunday you can attempt there, and it is a password protected form. You collect your password and attempt on only on Sunday. So in between 1st January 2023 to 28th February 2023. So in between you can join this one, and you can attempt this one. So on the based on selection, then second round will be there, based where you have to do some assignments, you have to do some projects, and accordingly we will select ultimately 10 students for this award. And at every phase you will get some certificate also, according to your merit, according to our your verification, because some of sometimes for certificate, somebody do some wrong things also, somebody upload some wrong things also. And for this thing, to avoid that type of errors, we have give in case of first round, 40% you have to score for certificate of participation. And you are, if you are in scoring 80% above, and automatically you are selected for next phase, second round. Otherwise our jury is there, they will select accordingly the meritorious and top scorers. Over to Chaniara sir.
Yeah, thank you, Anjanji. First of all, I would like to congratulate you because you are organizing such a very good webinar. So congratulations to you and your team also. And all the best to all the participants, students was taking parts in this competition. So my best wishes to all of you. You take part. That is very, very important because that shows your interest and confidence level. Don't worry about results. Results, it's okay whether you win or not win, but participation is very, very important. It's corrects your error by chance. Suppose you made some mistake, or if you are not prepared well, you can next time you can prepare well, and so it gives the chances to improve yourself. So participation is very, very important. So all the best to all of you for this competition. Thank you. Thank you very much.
Thank you sir, thank you sir. With these words, we are ending our session here. Thank you for being with us, and thank you sir also for being a long time with us and guiding us, even student also. Thank you sir.
Thank you. Thank you. Bye.
with these words, we are going once again to remind you that you have to join us. If you are a student of any stage, school, college, or university level, you can join 4.2 India International Sarabhai Student Scientist Award 2022, which is beginning from 1st January 2023 and continued up to 28 February National Science Day 2023. And in between this, at every Sunday, you can attempt on e-quiz as a first round. For selection purpose, you have to score 80%, and who will score 40%, we will provide them the certificate of participation, and who will be selected, and their name will be declared during on or before or after 28 February National Science Day, and we'll start the second round from onwards, National Science Day 28 February, and it will continue till May June, and the award will be given to 10 top scorer of second final level on 12th August 2023, which is the birth anniversary of Dr. Vikram A. Sarabhai, known father of Indian space program. So with these words, on this auspicious occasion, when we have get blessed with to meet Dr. Salazar from NASA Jhonson Space Station Center on the eve of launching of Artimis 1, and also when we are celebrating the birth anniversary of Dr. Professor Birbal Sahni, the father of Indian Paleobotanist, and also when we are celebrating National Children Day on 14 November. So with these words, I would like to end here, and namaste.